Hello everyone and welcome. Today I would like to talk about next permutation. This question can be a little bit confusing, so let me explain. First of all, the question will give you a number array such as 1, 2, 3, and it asks you to return the next permutation. So what's the next permutation? If you sort the elements and find all the possible permutation in order, then you can have the first permutation and the last permutation. And then it will be very clear to you the next permutation of 1, 2, 3 is 1, 3, 2. So you return 1, 3, 2 here. And the next permutation of 3, 2, 1 is nothing. So you return the first one as in here. But if you want to find all the permutations using a brute force solution, it will give you a space complexity of n factorial. And in contrast, the question asks you to implement a solution in space complexity of O1. So how can we do that? To solve this question requires some observation into the pattern among different permutations. And that kind of insight does not come naturally. Therefore, if you didn't have the experience of observing this pattern before, it might be a difficult question for you. Therefore, I rate this question to be hard just because that it takes some experience and observation into the pattern and generate that insight. Now, let's observe the order of permutations to develop some insight. So there are 6 permutations here from 1 to 3 to 3 to 1. Now let's pick 2 of them to develop some insight. So A and B, 2, 1, 3, and 2, 3, 1. We see that 3 things. I'll summarize here. First, the first few elements do not matter, like this 2 equal to 2. This did not help to tell us which one is previous or which one is the next one. Second, this is the last few elements that determine their order of permutation. This 1, 3, and 3, 1. Third, the 1, when you view from right to left, if it's in descending order, this 3 descend to 1 is the former one in the permutation sequence, like this 3 descend to 1. In contrast, if it's in non-descending order, when you view from right to left, this 1, 3 non-descending is the latter one in the permutation sequence. With this key insight, we can develop the algorithm as following. There are 3 steps here. Step 1, scan from right to left to identify the first element starting to descend, meaning the next permutation exists. Step 2, to find the next permutation, swap that element with the first smallest greater element among the right-hand side by scanning from right to left. And I will explain why we need to scanning from right to left here. Step 3. After swapping, sort the element in the right-hand side of index I to be in ascending order, going from left to right this time. Step 3 is to make sure that subarray in the right-hand side of index I is the first one in its own permutation sequence set. Here's one example to illustrate this algorithm. So we have this 13, 4, 5, 8, 6, and 1 array here. So step 1, scanning from right to left. We want to identify the first element starting to descend. So 1, 6, 8 increasing, but to 5 starting to descend. So we know the index is 2, 0, 1, 2. Index I equal to 2. Step 2, swap this element at index 2 with the first smallest greater element among right hand side when scanning from right to left. So 1 smaller than 5, 6 greater than 5, but it is the smallest. 8 greater than 5, so 6 is the smallest. We swap it, and then we have this 6 here. And now we can see this subarray A, 5, 1. If you view from left to right, it's in descending order. And we want to sort this part to be in ascending order, going from left to right to make it the smallest permutation in its own set. So after we sort it, and this can be simply achieved by reversing this A phi 1. And this is guaranteed because phi, after swapping into this position, must be smaller than 6. So this one must be in descending order for sure. And so after reversing it, we have this 1, 5, 8. Now the whole array is the next permutation. 13, 4, 6, 1, 5, 8. Here's the other example I want to use to illustrate this algorithm. So 4, 9, 1, 3, 3. So this is important. They are the same. And then let's see what happened. So scanning in step 1 from right to left. We want to find the first element starting to descend. So 3 equals 3, not descending yet, and 1 starting to descend. So we have index 2 again here. Step 2, swap this element at index 2 with the first smallest greater element among the right hand side by scanning from right to left. So 3 is greater than 1 and another 3 greater than 1, but this 3 here is the first one. So we swap it into this position and 1 go to here. Step 3. Now we can see this subarray is in descending order because it's guaranteed. After swapping, this element must be lower. So 3, 1. We want to sort this part to be in ascending order and going from left to right to make it the smallest permutation in its own set. And this can be simply achieved by reversing this 3, 1 to 1, 3. And now we can see why it's important to scanning from right to left, and also the first one, because if we are scanning from left to right, then we'll be swapping this three element here, and as a result, this subarray will become 1, 3, and that will cause a problem if we simply want to reverse the order of this subarray. So that's why we want to scanning from right to that and find the first smallest greater element here. Now, with all the background knowledge introduced, we can get to the exciting part, the code writing part. So let's get started. So first of all, we want to remind ourselves there are 3 steps here. Step 1, step 2, and step 3. So what are those 3 steps? Step 1, find the first element scanning from right to left. That is starting to descend. Step 2, swap that element with the first smallest greater element in the right hand side subarray of that element scanning from right to left. And step 3, reverse the order of that right hand side subarray. Okay. So that's all our 3 steps. As you can see, these 3 steps are very complicated, quite tricky. So you really need to know these 3 steps in order to solve this question efficiently. Now let's implement these 3 steps in Python. So step 1, we initialize uppercase I to be -1 outside the nums array range, and then we do a for loop to iterate through the nums array. So for I in the range nums array -2 decrease to -1, descending step by 1. We want to see if nums I equals the slopes less than nums I plus 1. So here you can see that's why we want to start with -2 here. So the nums I plus 1 is still within the nums array range. When we found this, the uppercase I will equal to lowercase I, and we break the loop. Step 2. You find this uppercase I, then we will swap the element, scanning from right to left. So for loop J from again the nums array, the last element, and all the way down to I, and with the negative one step down each iteration. And if nums J is now greater than our number, the element, we want to do a swapping. But so this is the greater part, but where is the smallest part? We want to keep track of the smallest by using a value and the index. So the full positive infinity to be the worst condition, and a negative 1 to track the index. So this way, if the smallest value is greater than the nums j value, we found ourselves a smaller element, and then we'll swap it in. So nums j, smallest value equals to that value, and smallest index equal to j. And this way we can keep track of the first smallest greater element. And finally, we do the swapping. So nums uppercase I and nums smallest index swap with each other in their value. So sorry, nums index, nums array uppercase I, and then finally we'll do the reversing. Nums uppercase I and the subarray. We'll do a slicing in Python. This way, we do the reversing order of the subarray, and we will replace with into the original subarray. And that's all our code for this question. And we can test to see how it works. Submit and judge it. Done. So let's see. 28 milliseconds. It's pretty good. And now let's analyze the code for complexity. So it has a time complexity on. We have two for loops here. One for loop for I and the other for loop for j. Both of these for loop can take to n. So the total time complexity is still on. And space complexity. Really, you can see we use a lot of in-place operation here, nums I, and so it's really just constant variable, so it's definitely the O1 space complexity here. All right, so that's all for this question. Hope you find this video to be useful. This question can be a bit difficult in my opinion. All right, so please stay tuned for more videos as I tackle all those difficult questions. Hope to see you next time. Goodbye.